Hello everyone, my name is Jaime Nunez and today we'll be presenting our Smart Systems case study. My teammates include Michael Farrell and Michael Farmer. Our agenda for our presentation today will include the introduction, statement of scope, Polywood's operation assessment, Polywood strategic operation enhancements, and we'll complete it with our conclusion. Polywood's journey towards smart manufacturing begins with a strong, sustainable foundation. As a vertically integrated manufacturer, Polywood transforms recycled plastics into finished outdoor furniture through recycling, extrusion, and assembly. This closed-loop production model already demonstrates operational strength and environmental leadership. However, the organization operates within a complex manufacturing environment. Variability in recycled feedstock, energy volatility, labor constraints, and transportation pressures create instability in performance and cost structures. The opportunity lies in leveraging Industry 4.0 technologies, not simply for automation, but for intelligent integration. Through advanced sensing, system connectivity, and data analytics, Polywood can move beyond reactive operational control toward predictive, data-driven decision-making. This leads us to the scope of our evaluation. Our focus is specifically on the Syracuse manufacturing operations, where they are recycling, extrusions, and assembly. These are the core value creating processes within the plant. We intentionally exclude upstream procurement and downstream distribution and sales. This allows us to concentrate directly on manufacturing system performance and plant level integration. Within the facility, our assessment centers on three key dimensions. First, current data acquisition practices, where data is captured and how it is used. Second, plant-wide integration gaps, identifying where the systems operate in silos and where predictive analytics capability remains limited. Third, operational performance opportunities, including scrap and rework reduction, energy optimization, improved schedule visibility, and bottleneck reduction. Today, Polywood demonstrates strong localized operational control. However, enterprise-level predictive analytics and plant-wide integration remain limited. The gap defines a transformation opportunity. To address this, we propose a structured enhancement roadmap. The Polywood enhancement proposal is designed as a 12-month implementation horizon, phased, disciplined, and measurable. The transformation follows a 7-phase structured rollout, beginning with baseline system design and KPI establishment, moving through process and layout optimization, upgrading equipment and integrating predictive maintenance, implementing energy efficiency initiatives, and deploying real-time data and MES integration, optimizing logistic and scheduling systems, and culminating in the stabilization and continuous improvement. At the center of this roadmap is Industry 4.0 integration strategy, connecting equipment, data, and decision system into a unified smart manufacturing structure. The objective is clear: improve process stability, increase material yield, reduce scrap and rework, enhance energy efficiency, improve bottleneck visibility, strengthen profitability, and ultimately, this is not simply an operational improvement plan. It is a structured transition from localized operational control to an end-to-end data-driven smart manufacturing enterprise.
Now that we've established that Polywood is an excellent candidate to integrate smart manufacturing into their production process, from recycling plastics to finished goods, as in outdoor furniture, we're going to look at an overview of the implementation roadmap. So there's a few key things we're going to talk about. First being value stream mapping and how the current production process works at Polywood. We'll analyze things like scrap and downtime. Where are there bottlenecks, and where can improvements be made? We'll also need to take an energy baseline. That way we can see how the current production process and how Polywood as a whole is using their energy, where their energy is coming from, and where there are areas to be improved and to be more energy efficient. Next, we'll establish KPI baseline, see where those key areas are that can help improve the process and keep workers on task. Last will be cross-functional alignment across all areas of the production line. Here on this slide, we'll review Polywood's enhancement proposal, which is a 12-month, 7-phase implementation plan, and this could vary. But this is a great starting point with phase 1, where we want to baseline and kind of start looking at a new system design or integration. So we'll do things like we spoke about previously, like value stream mapping and KPI baseline establishment. So seeing what those goals are that we need to improve, that we can get out in front of everyone in the company to work towards the same goal. We'll then move into process and layout optimization. So once we get those baseline assessments done and value stream mapping, we can look at where there are bottlenecks or where improvements need to be made. Where can we standardize work and deploy that out on the actual shop floor and processes. Next, we will look at equipment and automation upgrades. So is the current machinery and operations automation good enough for what we want to do and the improvements we want to make? Are there areas we can improve the machines, or actually buy newer machines that might help optimize the process? So a lot of times this can just be, we can make a good ROI just based off energy efficiency and how they are used within the process. Next, it kind of runs into the energy efficiency program. So energy is a very volatile space for a lot of companies, depending on usage, where the company is located, and how the surrounding area is developing. So how can we integrate LED lighting if it's not already being utilized? And one big improvement could be the compressed air optimization. Next, we would like to implement the MES process so that we can track each step of the production process and be able to track that from the very beginning of recycling milk jugs to getting the furniture to the customer's doorstep. Last, we will stabilize and continuously improve the process from a standpoint of Industrial 4.0. It's not going to be perfect right when it's rolled out. We'll find things that continuously work better and better, but there'll be a lot of things that we'll need, one being human capital, the people that are on the floor running the machines, process engineers and IT specialists, and the obvious as capital and digital investment. We're going to need the proper budget to execute these kinds of upgrades to make Polywood a smart manufacturing facility. In conclusion, we established that Polywood is an excellent, strong and sustainable manufacturing site that recycles plastics, extrudes that plastic into outdoor furniture. They have existing automation and sensors all around their factory floor, but new processes can be implemented to make the whole manufacturing process smarter and help move the company into Industry 4.0. We are going to do this with a 7-phase process that will take about 12 plus months. We will be looking at everything from baseline figures to how to improve energy efficiency and set up new automated equipment and utilize the data that is collected in the production process to make that process even better. It'll be a culture change, it'll be a company change, but it'll be a change for a better profit for everyone. Thank you.